Okay, now we're sketching a polynomial that's not a quadratic. This is a third-degree polynomial. And when you're sketching polynomials other than quadratics, it is helpful to know the parent graph. So when you have y is equal to x cubed, if there's a positive, there's not a negative sign in front, so it's positive, that general sketch is going to look like this. There's a negative sign in front. This graph will be reflected over the x-axis. So if it's negative, it will look like this. So again, you want to identify where it touches the x-axis. So when x is 0, because x0 cubed is 0, subtract 3, 0 squared, that's 0. 0 subtract 1 is negative 1. So we are going to, let me do this. Make sure those are all out in front. At 0, negative 1, we plot a point. Now, without getting into the polynomial theorems yet at this point, and other ways we can figure out how to graph this, what I recommend is finding a couple of values on either side, and we know the graph, the general graph, will look like that. So when we plug, I'm going to do negative 1, negative 3, and positive 1, positive 3. I'm going to do it rather symmetrically. And what you're going to do is you're going to, you can do this with your calculator, plug those x values, and I don't have a calculator handy. So when I put negative 3 in there, well, negative 3 cubed is negative 27. And I put negative 3 in there. Negative 3 squared is 9. Oh, 9 times 3 is another negative 27. Subtract 1. Well, we're down there at negative 55. So at negative 3, we are clear. That graph is going to be doing this. We're going to be down there at negative 55. I'm just going to do that. So now, we're going to do the same thing, but with ones. Negative 1. Negative 1 cubed, which is negative 1. Subtract 3 times negative 1. Well, negative 1 squared is 1. 1 times negative 3 is negative 3. So negative 1 subtract 3 is negative 4. Subtract 1 is negative 5. All right, so at negative 1, we're down there at negative 5. All right, doesn't look like any of our curves yet. So we're going to plug positive 1. So I'm going to make that go away and make that go away. 1 cubed is 1. Let me just do this. Positive 1 cubed is 1. 1 squared is 1. 1 times negative 3 is negative 3. Well, 1 subtract 3 is negative 2. Negative 2 subtract 1 is negative 3. So at 1, negative 3. So, oh, there's that curve right there. All right, now we're going to put 3 in and see what happens. 3 cubed is 27. Subtract 3 squared is 9 times negative 3 is positive 27. Those cancel, leaving negative 1. So at 3, we're down here at negative 1. Well, if I know the graph is supposed to look like this, I can use that information, and I know somewhere up here it's going to be doing this. It's going to be coming down, and it's going to curve back up, curve back down, and not a lot of effort. Now it wants us, I want you to be able to tell me the domain and range. Well, for all x to the odd polynomials, so x cubed, x to the fifth, actually x to the first, x to the seventh, all x to the odd, the domain will be negative infinity to positive infinity. The range will be negative infinity to positive infinity. Doesn't matter if it gets moved around, this is what the domain and range will be. And remember, the domain it's what the x's are doing, and the range is what the y's are doing. So if you look at this graph, and if you read from left to right, this graph, even though it looks like it's mostly going down, while it's going down, it's also going to the left. And while it's going up, it's also going to the right. So negative infinity to positive infinity. And for the range, that's the up and down. Well, look at this is infinitely going down, and it's infinitely going up. So for all x to the odd, the domain and range will be negative infinity to positive infinity. And that's it for that one.